In exercise 0 of this book written by SM Ahsan Hussain for MA Economics and for the students of such grades, the first question is given to us as x square plus 7x upon x, and they are asking us to find the limit a x tends to 0 for the following functions. In order to find the limits, if we will apply directly the value of x over there as 0, then the result will be 0 upon 0, which is uh, not suitable for us to find. So in that case, first we will try to simplify the two numbers by dividing them by x square upon x plus 7x upon x, right? On further simplification of the two, we are getting x plus 7. Now if you are going to apply the limit over there that x tends to 0, then your result will be 7. In part number 2, we are given ax plus b upon x uh, divided by cx plus d upon x, right? So again, if you are going to apply directly the limit 0 over there, it is not possible for you to solve. So what you will do, that you will you will solve the numerator separately and the denominator separately. When you will multiply the first uh, number ax by x upon x, the result of that will be ax square upon x plus b upon x. Likewise, the denominator can also be multiplied by the value of cx can be multiplied by x upon x. So in that case, you will get cx square upon x plus d upon x. Now this part of the equation can be further simplified as a x square plus b upon x and divided by, I am writing divided by cx square in this way, divided by cx square plus d, d, d upon x as plus d upon x, right? As a single denominator, I have noted the two values. Now I will change this division into multiplication, and I will reciprocate this part of the equation of the question. So I will get ax square plus b upon x multiplied by x upon cx square plus d. On simplification of x, the simplified form of the given question will be ax square plus b upon cx square plus b plus d. Now if you will apply the limits, that is x tends to 0, then both these two numbers will become 0, so the remaining value will be b upon d. So on application of limit, the result of this question will be b upon d. Likewise, if you are going to solve part 3, you cannot apply the limits directly. In that case, again, you have to multiply the given value by uh, its conjugate, right? The conjugate of the numerator will be square root of 1 minus x plus 1. The same conjugate will be multiplied by the denominator also, square root of 1 minus x plus 1. And you know that a minus b multiplied by a plus b can also be noted as a square minus b square. So your numerator will be looking like this, and in denominator you have the value x multiplied by root 1 minus x plus 1, right? uh, this square will cancel out the square root symbol over there, so we will have 1 minus x minus 1 in numerator and x into square root of 1 minus x plus 1 in denominator. 1 and 1 will cancel each other, and then x and x will also be cancelled out, so we have minus 1 over there. So minus 1 divided by 1 minus x plus 1, right? On applying the limits, uh, this x will become 0, so the final value on after the application of limit will be minus 1 upon 1, so that can be noted as minus 1. No, since this x will be 0, so it will be 1 square root of 1 under it, So we can write minus 1 upon square root of 1 will give us 1. 1 plus 1 will be 2, so it will be minus half. In part 4, we are given 1 plus x whole cube minus 1 upon x. For this purpose, we have to apply the formula of a plus b whole cube on it, and we do that it is equals to a cube plus 3a square b plus 3a b square plus b cube, and then minus 1 will come over here. Minus 1 is given, so it will be noted there, and in denominator there will be x, right? So we have replaced 1 by a and x by b, right? So now we can write it as 1 plus 1 square into 3 is 3, so 3 into x is 3x plus 3x square. By multiplying 3 1 x square, we are getting 3x square plus x cube minus 1 upon x. Now we can see that 1 and minus 1 can cancel each other, so more simplified form of it will be 3x plus 3x square plus x cube upon x. By dividing all these values by the denominator, that is x, we can get 3 plus 3x plus x square. Now in this expression, when you are going to apply the limits that x tend to 0, the final result of yours will be 3, because this and this will become 0. So on applying limit x tend to 0, part 4 will give you the value of 3. In this part number 5, which is the last part of question number 1, again we can apply the conjugate of the numerator. We know that a plus b, this is a minus b. On applying the on multiplying it by its conjugate, it will give us root 1 plus x plus root 1 minus x. The same conjugate that we have multiplied in numerator will be multiplied in the denominator also. So root 1 plus x plus root 1 minus x, right? Now we know that a minus b into a plus b gives us a square minus b square. So our a is 1 plus x root, so a square minus b is root 1 minus x, so it will become b square upon x into root 1 plus x plus root 1 minus x, right? When we will further solve it, this square and square root will be cancelled out, so the numerator will become 1 plus x minus 1 plus x upon x into 1 plus x square root plus square root of 1 minus x, right? Now plus 1 and minus 1 will cancel each other, and the result of these two will be plus 2. So we have plus 2x upon x into root 1 plus x plus root 1 minus x, right? This x and x will simplify each other. The result of that will be it will be plus 2 upon root 1 plus x plus root 1 minus x. On application, now we can apply the limit x tends to 0 over here. So these two x will become 0. So we have root 1 and root 1, root 1 and root 1, and they both are being added. So it will be 2 upon 1 plus 1, or 2. So when you further simplify it, the result will be 1. So it means that the part 5th value on application of limit on it as x tends to 0 will be 1. Hope this will help you in understanding question number 1. Thank you.